we're going to look at volume ratios of similar solids. Now, we've kind of done perimeter and area ratios before, but this one we're going to add volume. Now, the concept, all right, theorem 99.1 states that if two similar solids, similar meaning same shape, different size, have a scale factor of A to B, then their perimeter ratio will remain A to B. The area ratio will go A squared to B squared, and the volume ratio will go A cubed to B cubed. So now let's put that into practice here. Let me kind of show you what it's talking about. So this example 2 says the surface area of the smaller pyramid is 54 centimeters squared. What is the surface area of the larger pyramid? Okay, so we're talking about area. All right, talking about area here. So for the ratio of A to B, now how do we know what our ratio is? Well, we can use corresponding side lengths because they're similar polygons. All right, we know that they are proportional. So my A to B ratio, you could say is 15 over 6. I'm going to switch it and say 6 over 15. That is my A to B ratio. Now I'm going to go ahead and reduce the 6 over 15. 3 goes into 6 twice. 3 goes into 15 5 times. So my ratio is 2 to 5. Now what we already know is that since we're doing area, I'm not just going to keep my ratio A to B. I'm going to square each one. So in my 2 to 5 ratio, I'm going to need to square each number. Now, since we're solving for the surface area, I'm going to remove this 15 for a second. Imagine this is my ratio column. My other side is my surface area column. Well, I know the surface area for the smaller one, so the 54, well, the smaller one is on top. We put the 2 to 5 ratio, so the smaller one's on top. We want to know the surface area of the bigger pyramid. So that is how you set it up, and then you solve. So 2 squared is obviously 4. 5 squared would be 25. We multiply. Okay, so 4x equals 1,350 divided by 4, 337.5. So that would be my surface area of the bigger pyramid. Now let's look at one more. Let's look at volume, since we haven't done a volume one before. In example 3, it says the 2 cylinders shown are similar, same shape, different size. If the volume of the smaller cylinder is 38 cubic feet, what is the volume of the larger cylinder? So how do we know what our ratio is? Well, we can once again look at corresponding measures, or because there's no side lengths here. So we're going to use the radius. The radius of the small, I'm going to go small to large. The radius of the small is 2. The radius of the large is 3. So that is our A to B ratio. And remember, when it says for any A to B ratio, a scale factor of A to B, what we're going to need to do if it's volume now is we're going to need to cube our A and B. So we cube them. We put 38 on top, since that corresponds with the top with its own radius. And we need to find the volume of the bigger cylinder. 2 cubed would be 8. Go ahead and solve for that. 3 cubed would be 27. So we multiply, get 8x. 27 times 38. It's 1,026. Divide by 8. And you get 128.25 feet cubed. 128.25 feet cubed. And that is how you do volume ratios with similar solids.